Hello everybody, this is Meghraj and I welcome you to my YouTube channel. Today we are going to solve the next numerical from chapter electricity. So dear friends, this question was asked in board exam for 5 marks. Let's see what the question is. What is meant by heating effect of electric current? Give 2 applications of heating effect of current. So dear friends, listen to me very carefully. What is heating effect of electric current? When current is passing through a high resistance material. The material has very high level of resistance. In that case only the heat will be generated in that material if we pass current through it. So that is the main principle behind the heating effect of electric current. So that's what I have written here. That is, when current is passed through a wire of high resistance, it becomes very hot and produces heat. So the heat production is utilized for other purposes. So in this case, when we say wire of high resistance, we mostly use nichrome wire, nichrome or nichrome wire. Nichrome is an alloy, dear friends. It is made up of 80% of nickel and 20% of chromium. So that is nichrome. So it is used in the appliances, that is the devices like iron, toaster, water heater. So there is a use of nichrome in these devices, heating devices, because it has very high level of resistance. So dear friends, always remember, resistance in electricity or for electric current, resistance is as same as friction for motion. Okay, so means resistance is the opposition offered to the flow of current. That's the thing. So the 2 applications of heating effect of electric current is, one is for heating appliances like iron, toaster, water heater, we use that phenomenon, that is heating effect, and the other is electrical fuse for protecting electrical appliances. So there is a fuse wire inside. Nowadays we have a fuse, a small fuse inside almost every big device which consumes more and more electricity. So that wire melts up when large amount of current suddenly flows through the device. So in that case, it saves the device from high voltage or high current, high level of current. So that is the main thing. That is the main reason behind using fuse. Okay. So fuse protects the circuit as well as, or wherever you place the fuse. That is the main part. So fuse always protects from high current. Okay. Now let's see what the second part is. Explain why tungsten is used for making the filaments of electric bulbs. Now dear friend, you should know one thing very important about tungsten, and that will be asked for 1 mark in the board examination. That is its melting point. Tungsten has a very high melting point of 3380 degrees Celsius. Other than high melting point, it is also very highly, you can say it is high at flexibility, and it has very low rate of evaporation even at high temperatures. So these are the specialties of tungsten. That's why it is used as filament in incandescent bulb. That is the yellow colored bulb in which there is a man made up of glass standing like this, and there is a wire joining the 2 hands of that man. So that wire is made up of tungsten. And why it is made up of tungsten? Because it has a very high melting point. And when that filament glows bright white, at that time its temperature goes to around 2500 degrees Celsius. So these are the special properties of tungsten which makes it suitable for making the filament of an incandescent bulb. That is the yellow bulb that is generally used. That is cheaper in cost and generally used. Okay. So that's the second part. Now let's go to the numerical part. That is, 50 joules of heat is produced each second in a 2 ohm resistor. Find the potential difference across the resistor. Now dear friends, in this numerical, you have to be careful about what you have to jot down. So don't just blindly jot down whatever is given. Try to understand what is given. Listen to me very carefully. 50 joule of heat is produced each second in a 2 ohm resistor. So this is the heat produced each second. So what is it? Heat, that is the work done. Okay, because both have same units. Heat generated per second, each second you can say. So heat generated per second, that is work done upon time. So what is work done upon time, dear friends? It is the rate of doing work, that is power. So 50 joules of energy each second means it is power. That is 50 joules in 1 second. So the power will be how much? 50 watts. Now, what we have to find? We have to find the potential difference. And its resistance is how much? 2 ohms. So, first, what they have given indirectly. They have given power indirectly because they have said 50 joules of heat is produced each second. So that itself means 50 watt of power. So power is given, and we also know the resistance. What we have to find is potential difference. So this is the relation, dear friends. Okay. So P is equal to V square by R. And if you are not able to find this, go to the first video of this playlist. Okay, I'm giving you the link in the I button also. So in that, I've explained the 4 different formulas of power. The basic formula is P is equal to W by T. That is work done upon time. This is also one of the formulas. So here we have the relationship between power, resistance as well as the potential difference. So we have to find out the potential difference. So PR will go to P with the multiplication sign. So V square is equal to P into R. So what is P? P is 50 watts per and resistance is 2 ohms. So V square will be equal to 100. So root of 100 will be 10. And so the potential difference will be 10 volts. So dear friends, I'm going to focus mostly on concepts. So this was very important as per the aspects of heating effect of electric current. So that's all for today. Thank you very much for watching this video. I'll see you in the next video. Subscribe to my channel and hit the bell icon to never miss a video. Thank you very much.